We will conclude this section with one more example where we're going to find a general solution to the differential equation y triple prime plus 2y double prime minus 15y prime equals 36e to the power x plus 45x squared minus 57x. So the first thing we want to take a look at is the auxiliary equation. And the auxiliary equation is r cubed plus 2r squared minus 15r equals 0. And we see that we can factor out an r and we get r squared plus 2r minus 15 equals 0. And so we have r equals 0, or r minus 3 times r plus 5 equals 0. And that means r equals 3 or r equals negative 5. So all of this together tells us that the homogeneous part of the solution is going to be c1 e to the power 0x plus c2 e to the power 3x plus c3 e to the power negative 5x. So now let's take a look at that differential equation again, and I'll write it in factored form. So we had d times d minus 3 times d plus 5 of y equals 36e to the power x plus 45x squared minus 57x. So now we want to take a look at what is the annihilator on the right hand side. So here we have 36 times e to the power 1x. So the annihilator for that first part is d minus 1. And then annihilator for the second part, well, if you differentiate x one time, you get 1, and then you differentiate it another time, you get 0. So d squared would annihilate this. And similarly, d cubed would annihilate this. So what we could do is we could do d cubed times d squared. But that would give us unnecessary amount of coefficients for our particular solution, because d cubed works for x squared, but it certainly will also work for x. So don't use d cubed times d squared. It's not entirely wrong, but you'll get too many coefficients that you'll have to worry about. So we have d minus 1 and d cubed. So that together, so d cubed annihilates this. And so our annihilator A is equal to d cubed times d minus 1. So if we apply our annihilator to both sides, what we get then is d cubed d minus 1 times d times d minus 3 times d plus 5. And the right hand side, because we used an annihilator, will be 0. So clean this up a little bit. We see a d cubed and a d. That becomes d to the power 4 times d minus 1 times d minus 3 times d plus 5. acting on y equals 0. And now let's take a look at the corresponding functions. So d to the power 4, that corresponds with a root that's equal to 0. And so we have e to the power 0x, which is just 1, right? And then x e to the power 0x, which is just x. And then we have x squared e to the power 0x. And then we have x cubed e to the power 0x. So those are our functions associated with d to the power 4. D minus 1, that's associated with the root r equals 1. And so that's just e to the power x. And then d minus 3, that's associated with r equals 3. And that's e to the power 3x. And then we have d plus 5, that's associated with r equals negative 5. And then that's associated with e to the power negative 5x. Okay, let's keep track of the functions that we already found in the homogeneous case. That's e to the power 0x, e to the power 3x, and e to the power negative 5x. Those are all part of the homogeneous equation or solution. So now, what do we have left for the particular solution to this equation? So our particular solution looks as follows. It's x e to the power 0x. So let's start with the coefficient c4 times x, that's here, plus c5 times x squared, and then plus c6 x cubed, and then plus c7 e to the power x, that comes from here. So that is the form of our particular solution, and then we can combine those two to get the general solution. But since it specifically asks us to find a general solution and not just the form of the particular solution, we'll have to figure out what C4, C5, C6, and C7 are. And so what we need to do is we need to plug this into the differential equation and then try to figure out what are those coefficients. So we'll need yp prime, and that is c4 plus 2c5x plus 3c6x squared, and then plus c7 e to the power x. We also need yp double prime, and that is 2c5 plus 6c6x plus c7 e to the power x, and then yp triple prime of x is equal to 6c6 plus c7 e to the power x. And now we want to plug that in here. Okay, so y triple prime, we have c6 times 6 plus c7 e to the power x, right? And then we have plus 2 times yp double prime, that's 2c5 plus 6c6 x plus c7 e to the power x. And then minus 15 times yp prime, which is c4 plus 2c5x plus 3c6x squared plus c7 e to the power x. And then that has to equal 36 e to the power x plus 45 x squared minus 57x. So now I would recommend combining all the constants, combining all the parts that have e to the power x in them, all the parts that have x, and all the parts that have x squared. So let's see if we combine the constant parts, we have 6c6, right, plus 4c5, and then minus 15c4 right here. And that's it. Those are the constants. And then everything with e to the power x. We have plus c7 e to the power x, and then 2 times, so we have plus 2 c7 e to the power x, and then minus 15 minus 15 c7 e to the power x. And now let's take a look at the terms with x. This one right here has a 2 in front, so that's plus 12c6x, and then a minus 15 in front here, and so that gives us negative 30c5 times x, and then we have one term with an x squared, and we see that that is minus 45 c6 x squared, and then that equals 36 e to the power x plus 45 x squared minus 57x. Okay, let's rearrange that a little bit here. So we have 6c6 plus 4c5 minus 15c4, and then 1c7 plus 2c7 gives us 3c7 minus 15 is plus negative 12c7, and then we bring the 36 to the other side, minus 36 times e to the power x. Okay, and then for the x's, right here, we have 12c6 minus 30c5, and then plus 57, that takes care of that x there, negative 57x. And then finally, the last part is we have negative 45c6, and then minus 45 times x squared. And then the right-hand side is completely equal to 0. So now that gives us the following equations for the coefficients. So we have negative 45c6 minus 45 equals 0. Then we also have 12c6 minus 30c5 plus 57 equals 0. And then we have negative 12c7 minus 36 equals 0. And then finally, these coefficients all have to add up to 0. So c6c6 plus 4c5 minus 15c4 equals 0. This one is easiest to solve. So bring 45 to the other side, divide by negative 45. That tells us that C6 is negative 1. So now we can plug that in here and get 12 times negative 1 minus 30C5 equals negative 57. Add 12 to both sides and we get negative 30C5 equals negative we add 12 to that, so we get negative 45. And then divide both sides by negative 30, and we get C5 equals 3 over 2. This equation here becomes negative 12C7 equals 36. So C7 equals negative 3. And then finally here, for the last equation, we already have C6, that was negative 1, so we get 6 times negative 1 plus 4 times 3 over 2 minus 15C4 equals 0. So we then get negative 6 and then plus 6 minus 15C4 equals 0. That is 0, so it actually turns out that C4 equals 0. So that's a lot of work, but now we have our final answer. So the general solution to this differential equation is YH of x equals, the general solution, I want to write just y of x. The general solution y of x equals, and then first we take care of the homogeneous solution, right? C0 or C1 times e to the power 0x plus C2 e to the power 3x plus C3 e to the power negative 5x. So I want to just write that C1 and that C2. So I have my constant C0 plus C1 e to the power 3x plus C2 e to the power negative 5x, and then plus, and then I need to get my particular solution right there. C4 times x. C4 is 0, so that part disappears. And then I have C5x squared. So C5 was 3 over 2 times x squared. And then plus C6, well, that's actually a minus. So I have a minus x cubed minus x cubed. And then C7, that was equal to negative 3 minus 3, and then e to the power x. And that is my general solution. And so again, that general solution consists of yh of x, and that consists of yp of x.